we said that we use Bayes' theorem when we talk about the random experiment, sample space, the definition of event. Then we talk about the conditions that probability should satisfy. Then we talk about conditional probability. And also we talk about the total probability theorem and Bayes' theorem. In total probability theorem, we have the probability of an event using the conditional probability of that event. We said that BIs are the partitions of our sample space, and we prove this formula. In the Bayes' theorem, we said that we use Bayes' theorem when we have probability of A given beta and we need probability of beta given A. In such situation, we use Bayes' theorem. And finally, we talk about independent events. We said that two events A and B are independent if the probability of their intersection is equal to the multiplication of their probabilities. If you have any questions from the previous session, please ask me. No question. Okay. Today I'm gonna to talk about an example of total probability theorem and Bayes' theorem. What this example say to us? Suppose that a laboratory test to detect a certain disease has the following statistics. Let event that the tested person has the disease. Okay, event A means that the tested person has the disease. And event B means that the test result is positive. It's known that probability of B given A is 0.99. It means that the probability that the test result is positive given that the person has the disease is equal to 0.99. And the probability of B given A bar. What's the meaning of A bar? A bar is the complement of A. A bar is the complement of A. What's the meaning of complement of A? In this example, A means that the tested person has the disease, so A bar means that the tested person doesn't have the disease, okay? A bar means that the tested person doesn't have the disease. Okay, so the probability of B given A bar is equal to 0.005. It means that the probability that the test result is positive, but the person doesn't have the disease is equal to 0.005. Is this clear? Any question? Okay. And also we know that 0.1% of population actually has the disease. 0.1% of population actually has the disease. It means that the probability of a tested person has a disease is equal to 0.001. Because it's equal to 0.1% of the population actually has the disease. So the probability of the probability that a person has the disease is equal to this value. Okay. So the probability of a bar complement of a probability that a person doesn't have the disease is equal to this value. Okay, any question? this problem, what this example wants, what is the probability that the test result is positive? We should compute this probability. What is the probability that the test result is positive? Test result is positive. B, even that the test result is positive. So this example wants computation of probability of B. Is this okay? Any question? Okay. Can you say that how we can compute the probability of B? We know the probability of B given A. Also, we know the probability of B given A bar. But how we can compute the probability of B without any condition? Okay. Probability. This example says that 0.1% of population actually has the disease. Okay. So
excuse me, doctor, your voice is not clear.
From this population as disease is equal to this value. Okay, it's clear that the probability that a person doesn't have that disease is equal to 1 minus this value. Okay? Probability that a person has disease is equal to this, so the probability that a person doesn't have the disease is equal to
Doctor, please, your voice is not clear.
Probability
Doctor,
A.
Doctor, please. There is a noise from your side, doctor. Can you hear us, please, doctor?
A union of A and A bar is equal to sample space. This is our sample space. Suppose that this is our sample space. This is A, this is event A.
السلام عليكم شباب، صباحكم الله بالخير.
السلام عليكم ورحمة الله. صباح
شباب الصوت مو اخويا مهند المسعودي مفتوح، والمدرسة سوت ميوت على الصوت مالته، يعني بس تلقي المحاضرة وما يجي يبعث الصوت مالنا، فواحد تتأثر ولا تسمع. مهند المسعودي اخوي الله يحفظك، بس الميوت سوي على الصوت مالك. جزاك الله خير.
I can't hear your sound. For the problem that I mentioned at the beginning of the class, I turn off my speaker. Please type.
Excuse me, doctor, your voice is not clear.
The voice is not clear. Okay. Let me check.
Doctor, when you are talking, there is noise. Your voice is coming loud. I think there is some problem from your side, doctor.
Is my voice clear?
No, doctor, there is a lot of voice, a lot of noise come beside your voice.
Speaker, please chat. Because the problem that I said at the beginning of the class, I hear my own voice, so I had to turn off my speaker. So please type. Do you have my voice? Is my voice clear?
No, doctor, no, doctor.
I check. I exit the class and again enter the class. Perhaps the problem solved.
عيني. السلام عليكم. اعتقد الاستاذه طلعت وراح ترجع، بس اتاكد الصوت يعني صح. السبب بيها لو خاف من الموقع. اذا احد يسمعني خليه يجاوبني.
اعتقد من يمها، لانه من تبدي تحكي يطلع هذا النويز، ماكو هاي الصوت هذا الضوضاء.
صوتكم واضح شباب، المشكله من يمها واضح
اخوي من يمها.
لما كنا نحكي وياها ما كانت تسمع، من كنا نقولها صوتك مو واضح.
اي صحيح. زي معودة صوتك مو واضح ماكو.
هي اختي يمكن هم مالتنا مريضه، لانه صوتها شو نحس بيه بحى شويه.
والله ما لا اخويا، هي سوا قاعده بنص مع بعدها.
ظهر
بس خد تحمى شويه وشوف شو راح نسوي بينا.
انت معود تسجل ترى المحاضره مسجله خيك.
اي والله صح.
Okay, do you have my voice?
Yes, doctor, it's clear now. Thank you very much.
Do you have my voice? Please don't speak. As I said, I had to turn off my speaker. Is my voice clear? Please chat. Okay, let's continue. Okay. We said that if we have sample space omega and event A in this sample space A, complement of A bar is this blue region. So A union A bar union of A and A bar is equal to sample space. So the probability of A plus probability of A bar is equal to 1. So in this example, to compute the probability of A bar, we use this formula. یک minus probability 1 minus probability of A. Okay? Let's back to the example. Okay, probability of A is equal to this because the problem says us, and probability of A bar is equal to this value. Okay, any question? No question? Okay. Now, what's the probability that the test result is positive? What's the probability that the test result is positive? Okay, event B means that event that the test result is positive. So we should compute the probability of B. How we can compute the probability of B? What formula we should use? Could you say to me? Could you say? Could anyone say how we compute the probability of B? Base. Other answers, other students. Please pay attention that in this problem, we have the probability of B given A. Also, we have the probability of B given A bar. And now we want the probability of B without any condition. In such equation, in the previous session, we said that we should think of what theorem?
Total probability theorem.
As I said in the previous session, you should study the subjects of the slides. In such situation, as I said in the previous session, we should think of total probability theorem. Okay, when we have the conditional probability and we have the probability of, for example, in this example, event B without any condition, we should think of total probability theorem. Okay, we use total probability theorem, so the probability of B using this formula, total probability theorem, is like this. Probability of B is equal to probability of B given A times probability of A plus probability of B given A bar times probability of A bar. In this example, A and A bar are the partitions of our sample space. Partitions are A and A bar. As you can see in these slides, A and A bar are disjoint. It means that the intersection is empty, and also the union of A and A bar is equal to sample space. So A and A bar are partitions of this sample space. So we can use the total probability theorem and we can use this formula. Yes, Mr. Khafaji, we use these values in this formula. Now, okay, what's the probability of B given A here? Probability of B given here is this value. What's the probability of A here? We have the probability of A. What's the probability of B given A bar here? What's the probability of A bar here? We have this probability. Okay, from this formula, we can compute the probability of event B. Event B, what's the meaning of event B? The probability that the test result is positive without any condition. Okay, any question? No question. Let's go ahead. Here you see the solution of this problem that I wrote for you in the previous slides. Okay, but the next example. Okay, how can I get probability of A? Probability of A is given in the problem. In this example, in the problem statement, we have the probability of A because it says that we know that 0.1% of population actually has the disease. When we know that this percent of the population actually has the disease, it means that the probability of A is equal to this value. Okay? We have this value from the problem statement. The example gives us this probability, and we compute the probability of A bar. We have the probability of A from the example, and we compute the probability of A bar as I said. Okay? Any question? Let's go to the next slide. Okay. What is this example? This example is similar to the previous example. Again, event A means that the tested person has the disease. Event B means that the test result is positive. And we have these values and probability of A and probability of A bar, exactly similar to the previous example. But the question is now this. What is the probability that a person has disease given the test result is positive? Okay, again I repeat. What is the probability that a person has disease given that the test result is positive? Okay, the probability that a person has disease. A person has disease means the probability of A. Okay, it means that the probability of A. But in this example, given that the test result is positive, it means that given the
Doctor, please, your voice is not clear.
the test result is positive. So, in this example, we should calculate
Doctor.
this probability.
Doctor, please, can you hear us?
U and B. We don't have this probability directly from the example. We have the probability of B given A, probability of B given A bar.
ما شاء الله والله يسر.
We don't have probability of A
Doctor.
given B.
Doctor, please. The voice is not clear, Doctor.
The voice is not clear from you.
Doctor, there is a noise.
Is my voice clear?
No, Doctor. No, Doctor.
Oh.
There is a noise, Doctor. Like electronic van on the desk.
Now my voice is clear or not?
Yes, Doctor. The noise is gone.
Now is my voice clear?
Yes, Doctor.
Please answer. Is my voice clear? If not, I should try a different system. Okay. I try different system. Please wait.
اعتقد من تخلي الشاحن يطلع صوت الصوت من تخلي الشاحنه هذا الصوت يطلع.
شباب شنو ماكو صوت شنو؟
اعتقد يمكن احد تحول
لا ما
حاسبه
صوت.
ثانيه، حاسبه ثانيه او موبايل ثاني الله تشتغل بعد الله اللي يعلم.
Do you have my voice? Do you have
Yes.
my voice now?
Yes, Doctor, it's clear.
Okay, thanks. Okay, let's continue this example. As I said, in this example, we want to compute the probability of that a person has the disease given that the test result is positive. It means that we want to compute the probability of A given B. Any question? Okay, please pay attention that in this example, we have the probability of B given A, and we want the probability of A given B. In such situation, as I said in the previous session, we should think of Bayes' theorem, and we should use Bayes' theorem. So here we have probability of A given B is equal to What's the Bayes theorem? Bayes theorem is such this. So we should use this formula. So the probability of A given B is equal to probability of B given A times probability of A divided by probability of B. Okay, any question? Now we replace the values. Probability of B given A, we have this probability here. So probability of B given A is equal to this value. Probability of A, as we said in in this section, probability of A is equal to this value. But divided by probability of B. What's the probability of B? For computing probability of B, we now have the probability of B given A, and also we have the probability of B given A bar. Do you have my voice? Okay.
Yes, Doctor, yes. We have your voice. Please, if you can return to enjoy to us on Google Meeting.
Yes, I forget with this system to enter. Okay. I said that now we need the probability of B. Probably we have the probability of B given A and probability of B given A bar. But we need the probability of B without any condition. We compute the probability of B in the previous example. So we use the probability of B that we compute in the previous example, this formula, in the denominator of this fraction. So we have this formula for the computation of probability of A given B. In this example, as I said, we use the Bayes theorem. Any question? No question. Let's go ahead. Okay. But what's the next subject of this session? In this slide, as you can see, we want to speak about random variables. What is a random variables? Previously, we speak about random experiments, sample space, events, probability of events, characteristics of probability, Bayes theorem, total probability theorem, and so on. Now, in this slide, we want to talk about random variables. What is a random variable? Suppose omega is our sample space. Omega 1, omega 2, omega n are some events in this sample space. A random variable, please pay attention that a random variable is a function from sample space to the real value line. It means that in random variable, we assign a real value to every outcome of a random experiment. For example, if we toss a coin, our sample space in tossing a coin is head and tail is this set, head and tail. Okay. If we assign to head the value of 0, for example, and we assign to tails the value of 1, then we have a random variable, we call it x, that takes the values of 0 and 1. X is a random variable. A random variable is a function of or sample space to the real value line. In other words, in a random variable, we assign a real value to every outcome of a sample space. Okay, here x that takes the values of 0 and 1 is our random variable. Another example, suppose that we toss 2 coins. Toss 2 coins. When we toss 2 coins, our sample space is like this. Head, head. It means that the first coin is head and the second coin is head too. Head, tail, tails, heads, and tail, tails. Okay. In this example, in this random example, our sample space have 4 members. If we assign real numbers to each outcome of a random experiment or to each member of our sample space, we have a random variable. For example, we assign to HH value 1. We assign 2 to HT. We assign 3 to TH, and we assign 4 to TT. Now, we have a random variable that takes the values 1, 2, 3, and 4. These random variables take the values 1, 2, 3, and 4. This is x is a random variable. So again, I repeat that the random variable is a function from sample space to real value line, or in other words, to have a random variable, we should assign a value, a real value, to every outcome of our random experiment. Okay. But you should pay attention that the random variables may be discrete or may be continuous. You should differentiate in your mind between 2 types of random variables, discrete random variables and continuous random variables. It is clear that discrete random variables take discrete values and continuous random variables takes continuous values. For example, in tossing a coin, or random variable is x, x takes the values of 0 and 1. So this random variable that defined in this slide is discrete or continuous. Can you say in this slide x is continuous or discrete?
Discrete, doctor.
Yes. Here, x is a discrete random variable. In the next example, in tossing 2 coins, we have this random variable x, that takes the values 1, 2, 4. This random variable x is continuous or discrete?
Also discrete.
Yes. It's discrete too. But what's the example of continuous random variable? Suppose that we have a line segment from 0 to L. Okay, we have a line segment from 0 to L. We place a point in this line. We place a point, for example, a blue point in this line. This point may be here. or the point may be here, or the point may be here. The point may be here. The place of the point in this line segment is a random variable. Okay, is this random variable, if we call this random variable x, or random variable, determine the place of this blue point in this red line, in this red line segment. Okay, x, that is our variable, is continuous or discrete?
If it is
Yes.
continuous, it will be not discrete.
Yes, yes.
It's
X,
continuous.
yes, x is in the interval of 0 to L, so x is continuous. Here we have a continuous random variable. In this example, we have a discrete random variable. In this example, we have a discrete random variable, but here we have a continuous random variable. Or assume the value t specifies the duration of a phone call. We have a phone call, duration of a phone call. Suppose that t may be in the interval of 0 to t, duration of a phone call. Duration of a phone call. T is a random variable. That means the duration of a phone call. And it may be in the interval between 0 and t. Here, t is a random variable. Is it continuous or discrete?
Continuous.
Yes. Again, t is continuous random variable. Okay. Any question about continuous or discrete random variables?
Yes, doctor. The continuous, we can explore the t as a curve and the variable under the curve of t. That's mean, you know?
Pay attention, please pay attention that in this example, t may be a value in this interval, but we don't know.
Okay, that's mean.
Okay.
I confused for this.
Okay, here. Okay, it's very important that you pay attention that a random variable is discrete or continuous, because the analysis of discrete random variables and continuous random variables are different from each other. Okay, any question? Let's go ahead. Now, we want to fully understand the random variable. We want to fully understand and fully analyze a random variable. What we need to fully understand a random variable? We should pay attention that we are faced with a continuous random variable or with a discrete random variable. If we encounter with a discrete random variable, if we have a discrete random variable, to fully understand the discrete random variable, it's enough to know the PMF of this random variable, probability mass function, or in brief, PMF of this random variable. So for a discrete random variable, knowing the PMF of this random variable or probability mass function of a discrete random variable is enough for us to fully understand the discrete random variable. But what's the meaning of PMF of the random variable? How we define the probability mass function for a discrete random variable? For a discrete random variable, we use this notation for PMF. And PMF at every point, for example, suppose that we have a discrete random variable x. We have the discrete random variable x. X takes the values x1, x2, and so on. PMF of this discrete random variable specifies for us that this random variables takes x1 value with the probability of p1, x2 value with the probability of p2, and so on. So, having the PMF of a discrete random variable, we have the probability of different values of this discrete random variable. Okay, as you can see in this plot, in this example, we have a random variable x. X takes the values 0, 1, 2, and 3. What are these bars? It means that it's the PMF of this random variable, and it means that this random variable x takes the value 0 with the probability of 1/8. This random variable x takes the value, for example, 2 with the probability 3/8. And this random variable x takes the values 3 with the probability 1/8. Okay, this is the meaning of PMF. PMF very simply specifies for us the probability of different values of a discrete random variables. Any question? Is my voice clear? Okay. Again, back to this example. This example, tossing a coin. Our random variable is this. X takes the values 0 and 1. Okay, if we have a fair coin, it means that the probability of heads and probability of tails are same, are equal to each other. Fair coin means the coin that the probability that we have tail and we have tail and heads are equal to each other. So what's the PMF of these random variables? Okay, this random variable take the values 0 and 1. Now, what is the probability of that this random variable takes the value 0? Can you say?
1, 2, 1 over 2?
Yes, 1/2.
1/2.
And what's the probability of this random variable takes 1?
It's equal to the...
Yes, it's equal. Okay. Any question? Other example. In this example, tossing 2 coins, we have this random variable x that takes this value. So if we want the PMF, we should plot such plot. Okay, again, suppose that we have 2 fair coins. Probability of head and probability of tails is equal to each other for 2 coins. Can you say what's the PMF at 1?
Quarter, Doctor. 1 over 4.
Okay, yes.
For all of them.
Yes, exactly. Thanks. Okay, any question? So it's clear that the summation of the values of PMF should be 1, should be equal to 1, because a random variable takes the values 1, 2, 3, or 4. And if we sum the probability of different values is equal to 1. Okay, any question? Okay, in this example, suppose that we ask you to compute the probability of this event. Probability that the random variable x is greater or equal to 2. We use the PMF to compute this probability. Can you say me what's this probability? How we can compute this probability using this PMF? We want to compute the probability that random variable x, that its PMF is like this, is greater or equal to 2. How we can compute it?
We have two probability, Doctor, 3/8 and 1/8.
Okay, thanks, very good. Probability that x is greater or equal to 2, it's the probability of x is equal to 2 plus probability x is equal to 3. And from PMF, we have these values. Okay. If we have the PMF of random variable, we fully understand that random variable. But again, pay attention that we can define PMF for discrete random variables. Okay? Any question? Let's go ahead. It's very important to pay attention that we cannot define PMF probability mass functions for continuous random variables. Why? Because when we are faced with a continuous random variable, when we have a continuous random variable, the probability that a continuous random variable is equal to the specific value is 0. Okay? Here we have a continuous random variable that takes the values in this interval. Here, if we write this probability that x, for example, random variable x is equal to a specific value, for example, x0. Suppose that x0 is here. X0 is here. The probability that a continuous random variable is exactly equal to the specific value is 0 because it's continuous, okay? We have infinity numbers that are continuous in the intervals between 0 and L. So the probability that our random variable is equal to the specific number in this interval is equal to 0. Because we have infinity numbers of points in these intervals. They are continuous. Okay? Okay, so we can't define PMF for a continuous random variable. But how we can fully understand a continuous random variable? Now we need to define a different function. We defined cumulative distribution function or CDF for continuous random variables and also for discrete random variables. We can define CDF or cumulative distribution function for discrete random variables too. Okay, so the CDF can be used for continuous and discrete random variables both. Okay, What's the meaning of CDF? How the CDF function is defined? Here we have the definition of CDF. We use this notation for CDF. CDF of random variable x at a point x. At a point x, the CDF is like this: probability that a random variable is less or equal than the value of x. Okay, so the CDF at every point specify for us the probability that a random variable is less than this value or equal to this value. Okay, CDF at every point, the value of CDF at every point specifies this probability at this point. Okay, suppose that we have a random variable x that takes the values 1 and 0, 1 with the probability of p and 0 with the probability of q. Here we have the CDF function of this